Assalamu alaikum everyone. Welcome back to the online lectures of the Operating Systems Lab. I'm your instructor, Engineer Mian Ibad, and today we will be covering a lab based on the topic of process creation and execution in Linux. This is marked as Lab 6 in your lab manual that I have already provided you, and by the name of process creation and execution. Okay, so before starting the practical implementation, let me just give you a little bit of the theory based for this lab. Basically, what is a process? As you already know, that process is basically it's just a program. It's just a single program, but it is in the execution mode. A program in execution is known as a process. If you are running an operating system, there are hundreds of thousands of processes running in the background and in the foreground, starting from like login, starting from the task managers, starting from different files, the C files that you are running, the different drivers. All of these processes, all of these programs, when they execute, they become a process, and all of these processes are running whether in your background or in the foreground. Okay, so there are two types of processes: a system process and a user-defined process. A system process is like it is handled by your own operating system. Like for example, login is a process, update is a process, and so on. Likewise, like for example, if you write let's say a C program having maybe let's say you make a TikTok game in a C program and you run it, then it's a process, a user-defined process. Okay, so as you people already know that Linux is having a hierarchical structure. Like there is a process, then it has child processes, as we have already discussed in the labs that we took in the university. So there is a process, an initial, a root process, then it has different child processes of every parent process. Okay, so the first process whenever you boot your Linux, that is known as an init process. Init process is the first process when you boot your Linux. Right. Now, every process in Linux should have a process ID, also known as a PID in short, process ID. So the first process, that is the init process, it has a process ID that is a PID of 1. Init has a PID of 1. Right. Now, PID of 1, that is init, it produces different different child processes, and if a parent process produces a child process, all of the code and different properties of the parent process is copied directly into its child process. So then the parent process and the child process continues to do one work. Then you make differences in the child process and it does some other job. Okay, so init has a PID of 1. Then after that there comes another process, a child process. It gets a PID of 2, 3, 4, and so on. Then when you make, let's say, a C program, once your Linux is booted, so it might have a process ID of, let's say, 2000, 3000 based on the previously running processes. Right. So how do you know that what's the process ID of your, or PID of your process that you have just made? It is, you can get the process ID of any process by using the C programming function of PID, get PID. Once you write get PID, you will get the process ID of that particular process. Okay, if let's start with the terminal, so you will have a clear idea. Let's say I write here PS. So these are the two processes, 2713, 2723. Let's say these are two processes. It has a PID, and these are the processes of this command line. Then we come towards the inheritance. So what does a child inherit from its parent? It inherits the following attributes, like it inherits the code that the parent is already running. It inherits some of the data. It inherits the stack, and it also inherits okay, it doesn't inherit the process ID of the parent. It has got its unique process ID. So child process has this some code from the parent process, some data from the parent process, and a stack from the parent process, but it has got its own process ID, that is the PID. Okay, so now, okay, let me just show you a visual representation of processes. Let's come here. Okay, so as I've already told you, this is the first process when a Linux boots. So init, and it has a PID of 1, and it has a child process of kthread that has a PID of 2. It has some other child processes that has it has a PID of 6. PD flush has a PID of 200. Then it also have, so all of the below, let's say this is init, it's a parent process, and these are its child processes. That is login, it has a PID of 8415, kthread of a PID of 2, SSHD has PID of 3028. Now SSHD has a child process of 3610. Then it has a child process of TCSCH, and it has a PID of 4005. Likewise, again from the init, this is its child process, login 8415. Then login has the following child processes, that is bash. So 8416, bash has child processes 9298, 9204, and so on. So what can we get from this diagram? It says that every process that is running in the Linux should have init as its parent process by some stage. Let's say if you talk about, let's say, this PS having a PID of 9298, so at some stage it will get to its parent. Like PS has a parent of bash is a parent of login, and login has a parent of init. So this is how the Linux structure works. This diagram, this representation, is known as a process tree. You people must should already have covered trees in the programming, C or C++ programming. How do you create trees? So this is basically a process tree. It has different leaves and a root node and so on. Okay, this is about process tree. If you take, let's say, this one branch of this tree, so this is known as a process chain because it has a one-to-one correspondence with each other. SSHD has only and only one child, and this again has only and only one child. So this, only these three, if you consider only these three, so this is a process chain, right? So this was just a visual representation. Now let's have a look at the lab manual. It has some information. Okay, so process identification. As I have already told you that you get to know the PID, that is the process ID of a process, using the keyword get PID. So where do you store this PID? You store this in a data type of PID underscore T, and this data type is present in the library unistd.h. So if you don't have don't add this in your header, the PID underscore T won't work. Okay, so you store your PID in PID underscore T as a data type. So for the process ID you use get PID, and to know about the parent ID of a process you use get PPID. So get PPID means get parent process ID, right? So to know the process ID of the process you are running, you have to use get PID, and to know the parent ID of that process you have to use get PPID. Right. So how do you create a process? The process is created using the keyword fork. If you're running a process and you use the keyword fork in it, it will replicate the process in a child process, and all of the properties of the process you are running, it will be replicated into its child process. Okay, it is the keyword fork is here in unistd.h library. Right. Okay, so once you execute the fork command, it returns a value which is again stored in PID underscore T data type variable. So it returns two things. Either it returns a value of 0 or it returns the PID. It says that if the operation is successful, then there are both parent and child processes, and both see fork return but with different values. If it returns 0, it means you are in the child process, and if it returns child process ID, it means if you are in the parent process. So if you are running, let's say, a code and you write the keyword fork, it would return a value. If the value is 0, it means that this, and then you execute something and it gets executed, it means that you are in the child process. But if it returns anything more than 0, it means that you are in your parent process, and the value that has been returned from the fork, that is the child process ID. Right? So it will just get clear once we implement it. And if the process creation is failed, that means the fork that we have just used, it fails. That means that it cannot create a child. Then it will return a value of -1 in the parent process, and no child is created. Right, these are some of the attributes. You may just go through it once you create a process. So some of the attributes differs from the parent process. Right, so let's go to the terminal again, and let's see where I am. ls, okay, I have to go to work now. ls operating system, ls lab4, okay. Now let's create a C programming file. We have already covered it. gedit, let's say file, or let's say test.c. Okay, so I must say that I won't be writing the code to save the time and to save the memory of this video, to shorten it. So I would just simply copy and paste the code, and I would make you understand what is there in the code. I would say that you people, it's preferable that you people should write the code so that you learn how to code this process creation. Okay, so I have imported the library of stdio.h, and for the fork and other functions I've used unistd.h. okay, simply int main. Okay, what would it do? It would, okay, one thing I must say before it, that at this moment you should have a pen and a paper, and you should replicate the process creation on a page. That, let's say, if I have a parent process, then it has then it gets a fork, and it gets its child processes. So you will have a clear understanding and imagination basically of how this process creation works. So first of all, it would print hello world. Then I have written fork. What does fork mean? It will create a child process. Once it is created, so everything in this code is replicated into another process that is the child process of this process. So it will print hello world, then a new process is created, then it would print I am after forking, then it would print I am process and get PID of the process. So it would say, let's just run it, save, let's just run it. To run the command I would use I would first compile it, test.c-o test. Okay, so there was no error. Now let's run the file test. Okay, now let's just see what we have here. Okay, first of all it would print hello world, hello world. Then the fork is executed. It means that a new process has been created. So it says I am after forking, I am after forking. Then it says I am process get PID. So it says I am a process 25275, right? Then it says again I am after forking and I am process ID 25276. So clearly you can see that these two lines of code, these have been displayed by or run by the parent process, because it has one ID lesser than its child process. It is 75 and it is 76, and the same code, it is replicated into its child process. So it again says that I am after forking and I am process 25276. Let's say I run it again. So you can see that we get the new process IDs, because this is now a completely new process. So again it says that hello world, hello world, then it creates a new process, then it says I am after forking, and I am process get PID. Get PID would get the process ID. So I am process 25278. So most probably, or this is basically the execution of the parent process, and then again this is the execution of its child process. Okay, we cannot say that whether the child process will execute first or the parent process will execute first, but you can just get an idea from its PID. Let's say I run it again. So now you can see that it says I am after forking, then it says again I am after forking. It means this was executed by the parent, then this was executed by the child, then this by the parent, and then this is by the child. So it depends on how the process is running in the back end of your computer in the CPU. So it depends on that. Let's run it again for another try. So it does it again. Now if I run it again, so this is the parent and this is the child, right? I hope that is understood. Now let's proceed further. Okay. Let's copy paste this code. Let's open the gedit. See, paste it here. Okay, now what's happening in this piece of code? Just have a look at it. So what would it do? First of all, it has to print hello world, then it will print I am the parent process and PID is get PID. So this would, when this line is executed, it would display the process ID of this very process that we are, this very program when it becomes a process. So it's the PID of this process. Then it would say here I am just before the forking, right? So just before the forking. So first this line, then this line. Then we would create a process, and its return value will be saved in this variable, that is PID. Right. At this moment, a new process will be created, and everything in this code will be transferred or replicated into its child process. So after this, the parent and the child process will execute these codes. Before this fork, only parent will execute this code, right? But once the fork has been executed, a new process is created. Then after this, this piece of code will be executed by both parent and child process, right? So once the process is created, it will print, let's say the parent process is executing this piece of code. So the parent process would say, here I am just after forking, and then we have the if statement, and it says that if PID is equal to 0. So what does PID equal 0 means? That this is a child process. I've already told you that if the fork returns a value 0, it means you are currently in the child process, and if it returns a value greater than 0, it means this is the child process of your parent process. That means you are currently in your parent process. And if it returns a -1, that means that the process creation was failed. You can also add if PID is equal to -1 in an if loop, so just to catch the error. Anyways, let's say I am in the parent process. This piece of code is executed at the parent, and so it would say if PID is equal to 0, then execute this, else this. So if you are in the parent process, so this would be skipped. So it would just go to the else, and it would say I am the parent process and PID is get PID. So this PID and this PID would be the same, because this is the parent process. And now let's suppose that the child process is executing these lines of codes. So it would again say that here I am just after forking, and if PID is equal to 0, that means you are in the child process, and we are assuming that currently we are in the child process. So it would say I am the child process and the PID is get PID. So this PID would be different than this and this, because these two are the parent process IDs, and this is the child process ID. I hope you have understood it, but let's run it to have a clear understanding. Right, so let's first compile this code, now run it. Right, so first of all it says hello world, and it says I am the parent process and my PID is 25308. Remember this PID. The process ID is 3025308. Then it says here I am just before the forking. Till this piece of code is only and only executed by the parent process. Then we use the fork statement. It means a new process has been created, and the return value of the fork is stored in PID. So now both of the parent and child process will execute this piece of code. So here it says just before forking, okay, this piece of code is executed by the parent just till this. Now it says here I am just after forking. I am the parent process. It means that this piece of code is now currently executed by the parent, and the PID is 25308. What it says here, I am just after forking. It comes here, and PID is not equal to 0 because this is the parent process, so it will come here and it would say I am the parent process and my PID is get PID. So you can see that the parent process ID is same, 25308 and 25308, and then again the same is executed by its child, and it would say that here I am just after forking and I am the child process having 25309 as my process ID. So I hope you have understood technique. Let's run it again. So let's see if there's any change. You can see the process IDs are incrementing because the previous processes are already there. So it is giving it a new process ID. So now you can see that the implementation is a little bit different, the execution is a little bit different. That depends on the CPU. Okay, let's clear it out. Now let's see what we have further. Okay, this piece of code you have to implement it using your own computer, because again I would say get a pen and a paper and just replicate whatever you see here using your pen and paper. So let's say if I have this as my parent process, so just write a parent process here, a parent process, then make a line, let's say a line, and it says a child process. So there you have a child process. So this was one parent and child relationship. Here you will have a multiple child and parent relationships. So this piece of code will make a process tree that I have just showed you. So, but just for your understanding, let's reopen the file. Let's save it. Let me explain what is happening in the code. First of all, I would again say just get a pen and paper, because that is the easiest way to imagine and to understand this mechanism of process creation. If I tell you about my own self, I have also learned, because this is very confusing, the process creation in Linux. So without pen and paper you will not be able to imagine it. So I've already learned it the same way. So what does this piece of code do? First of all, this line of code is only implemented by the parent process. It says that here I am just before the first forking statement. Okay, so the output of this program will be very confusing because it has 3 forks. It means it will create many processes. How? Parent process executes this code, then it comes here. It says fork, so a new process is, a child process is created. Now this whole code will be executed by the parent as well as the child process created here. So let's say now we are in the parent process, so it would again write, it would display here I am just after the first forking statement, and it would again make another process, then another process. But the same code will also be executed by the child that it has created previously. So this code will, so the child will also create 2 other children. Then this child would again create 2 other children. Then this, so this piece of code will be executed how many times? Let's see. So let's just let's run it. So now you can see that it has been implemented several times. Let's check it out. It first says I am here before the first forking statement, then it says I am here just after first forking statement. A child process has been created, then after first, again after first, then second, third, second. So this replication is done because of the multiple fork statements. You just get a pen and paper, you should you should draw the process creation there, so you will get to know this output very easily. Just think over it, just contemplate a little bit, and by the brainstorming you will definitely know what is happening in this piece of code. Okay, so for the just a hint, hello world from process get PPID. So just have a look at the PID of every statement, so you will get to know that which process is the parent of which child. So it would make a process tree. Let's say 25352 and then 25353. So this means that this is the child of this. Then okay, you can clearly see that 25352 is the parent ID. You can also write here you can also write here about the get PPID. So you will get to know that what is your parent ID, right? So this is the parent ID. It has various children, so get to know this using your own understanding. Okay, now let's move towards the exit status. So if you use exit in a process, it means it is terminated, and it also returns a value. If the value of the exit statement is 0, it means that the termination of the process was normal, and if it is any other value than 0, then it means it has the process termination had some sort of problem. So there are various problems that we will cover later on in the course, so no need to get into this at the moment. Okay, then there are some other elements like a process may suspend for a period of time. Suspend means it will wait before execution using the sleep command, and in the you pass this number of seconds to the sleep command. For this, let's execute this one. I hope it has the. Let's see what's in the code. Okay, just keep a track of these libraries. Okay, so what does this program says? First of all, it would print I am the parent, remember my number as this. Then it would say I'm now going to fork. It means I'm now going to create a new process, a child process. Again, it would be the same as this parent process ID. Now a new process has been created and the return value is stored in fork result. Now if fork result is not equal to 0, it means you are in the parent process. So it would say my child's PID is that has just been created here using the fork is this, right? And then if it is not in the parent process, it is in the child process, that means the fork result is equal to 0. It would say hi, I am the child process and my ID is this. Now we have come out of this loop, so it would simply say like father like son, and the process ID of the parent or the child will be executed twice. So let's save it and let's run it. Let's see what happens. Okay, there is some error. Okay, so there was just a small issue in the code. So let's open the code. I've written it again. basically the problem was there were unnecessary spacing in the code that I just copy paste, so I just rewrite it. Okay, now let's save it. I should tell you again what does this code do. So it says that first of all, the parent executes I'm the parent, remember my number, and this is the its ID. Then again it's gonna say I am now going to fork with the same ID. Now after this, the code has to be executed by the parent as well as the child. So once the fork is executed and its value is returned in fork result, so if the fork result is equal to 0, it means it's the child, and if it's not 0, it means it is, or greater than 0, it means it's the parent process, and this the value returned by the fork is its child's process ID. Okay, so if it is not equal to 0, it means that it is the parent process. So it would say that my child's PID is the fork result. This D is this get PID, so this would be the parent ID, and this D is the fork result. So fork result is basically the child ID. And then if it is not okay, this one would be skipped, and it would again say that like father like son, and it would again display the same ID, that is the parent ID. So get PID, this one, this one, this one, and this one would be same. Now this has to be executed by the child as well. So if this is the child process, so these lines will be skipped, and it will come to else, and it would say that this get PID would be now the child's ID. It would say hi, I am the child, and it would also execute this one using the child ID. So let's go and first let's compile it, no errors, that's good, and let's run it. Test. Okay, now let's understand the code. Yeah, it is saying that, so the parent ID, like the first process which has to create a new process, its ID is 59260659. So 20659 says that I am the parent, remember my number. I'm the parent, remember my number. Then it says I am now going to fork. The parent says. Now after this, it says this is the parent process. It says that my child's PID is 26060. The parent ID, it says that my child's PID, because it's a parent process, so this one line is executed. It says that my child's ID is this, that has been returned in fork result. So my child's PID is 26060. Then it says that this one is skipped, and it says that like father like son. 26059 says like father like son. Then 26060, then now these lines of code are being executed by the child process. So this one is skipped because it is equal to 0. So it says that hi, I am the child process. So 26060 says that I am the child, and again this one is also executed. So understanding the fork, you should pause the video or just reverse the video and study it again and again using a pen and a paper, so you will get to know what is happening in the execution. Okay, then we have different sort of processes. One of the process is known as zombie process, the other process is known as an orphan process. These are the opposite of each other. Zombie process is a process which is executing an orphan process is a process which is executed after when its parent dies. So when its parent process dies, it means it's an orphan child. What does it say? When a process when a parent dies before its child, the child is automatically adopted by the original init, that is the PID number 1. It is adopted by init process whose PID is 1. To illustrate this, insert a sleep statement into the child's code. So in this command, in this code, what we will do, we will insert the sleep command. So when we input sleep in the child process, so the parent process will be it will be executed and it will be terminated. So it means that the parent dies before its child. So its child process, which will be having the sleep command, because the sleep makes the command into a waiting state. So it would wait for 4 seconds, let's say, or 5 seconds, whatever we pass the value. So it will wait for like 5 seconds, then it would get executed as an orphan child, as an orphan process. So it means that it will be having a PPID, that is its parent process ID of 1, because it will be adopted by the init process. So let's copy and paste. Okay, so what does this program do? Some issues. Main void. Again, it would be having the same problem. Also add the other libraries actually. Hashtag include. What are the libraries? It's just unistd.h, unistd.h, and stdlib, and another one would be syswait. stdlib, syswait. Save it. Okay, so first of all, a PID is defined. The parent process says that I am the original process with PID of this, and my process and my parent ID is this. Then it produces a child. It duplicates a new process, and the return value is saved in PID. So if PID is not equal to 0, it means it's the parent process. So it would say that I'm the parent process with PID this and my parent ID this, and my child process ID is this PID, which was returned in by using fork. So my child process is this. So this piece of code would be executed in the parent process. Then this would be the else statement would be skipped, and it will again print PID, get PID. This is the parent ID. So this has been terminated. Now if it's the child process, it means that it will be skipped and it would directly come here and it would wait for 4 seconds, and it would say that, then it would say I am the child process with PID this and PPID. So what would be the PPID here? Basically the PPID here would be the init, that would be 1, because it has waited for 4 seconds and its parent ID is its parent process has already executed and terminated. So now it's an orphan process, so it's PPID, its parent ID, because it has been adopted by the init, so it would be 1. I hope there are no errors, because it has again a spacing problem. It has problem. Let me just pause the video and remove the spaces. Okay, so again there was some syntax error. I had to solve it. I would strongly recommend that do not copy paste the code, because there is an encoding difference in both this office and as well as the terminal gedit. So just write the code. It will help you learn and as well as keep you away from errors. Okay, so I've just recompiled the code. It works well. Now let's run it. Okay, so now let's understand the output. First of all, it would say that definitely the parent would say that I am the original process with PID this and PPID this. So it says that I am the original process with PID 26189 and its parent is 25648. Right, then we have instantiated the fork. We made a new process and its value is stored in PID. So it says that if PID is not equal to 0, it means we are in the parent process. It would say that I am the parent process with PPID 26189. You can see that both of them are same, and still its PPID, its parent ID, are also same. And it also says that my child PID is this PID that has been returned in this. So my child PID is 26190. Alright, now this section is skipped because this section is for the this section is only applicable to the child process. So it would say that PID this terminates. It says PID 26189, that was this process, it terminates. So 26189 terminates. It means that at this moment the second process, that is what we call it, the child process has not yet been executed, so it becomes an orphan process. So this process terminates, so the orphan has to be adopted by the init. So then the child process says that I am the child process. I am the child process, and my PID is 2610 and my PPID is 1. So now it means that it has been adopted by init, and it's a orphan process. And then again 26190, that is the child process, also terminates. So this was about the okay. So these are now some of the tasks you have to code and execute. It still have it's very simple tasks, just execute them. This is used for making process trees. So then there are also 2-3 tasks at the end, that is task number 4 and 5. In this you have to create a process fan. This is process fan, and you also have to create this process fan and chain. Okay, so task number 1, starting from here, task number 1, 2, 3, 4, 5 and 6. These are your lab assessment tasks. So please submit the lab assessment tasks before the due date, and if there is any problem in the understanding of this video lecture, so please let me know. Let UCR know, first of all, they'll let me know, or just you can directly email me on my official email address. So thank you so much, and I hope you have learned about the process creations in Linux. So just practice it, and thank you so much. Take care.